Hello. In this lesson, we're going to learn about conversions within the metric system. So why are units and conversions important? Units are important because they give meaning to a number. So for example, if I tell you 25, that number 25 doesn't make any sense. But if I tell you 25 students or 25 meters, now that number makes a lot more sense, right? 25 students is referring to the number of students, for example, in a class. 25 meters is referring to a measurement of length, for example. We may need to convert from one unit to another unit to make the unit more appropriate for what is being measured. For example, I wouldn't give you my height in miles, right? But I would give you my height in inches, or maybe a combination of feet and inches. But I also wouldn't give you the distance from Los Angeles to San Francisco in inches. I would give that to you in miles. So sometimes we have to convert from one unit to another unit to make the unit more appropriate for what is being measured. In this lesson, we're going to be talking about units within the international system and converting between different units. So we're not going to be talking about the English system, such as feet and inches and ounces and pounds, but rather talking about meters and kilometers and grams and units and conversions within the international system. So this, what I'm showing you guys here, is prefixes that are in the international system. And these prefixes get added to a base unit to make the unit either larger or smaller. So whereas in the English system, for example, we have inches and feet and yards and miles, and each of those conversions is a different number, in the metric system, we have the same base unit. For example, meter is a unit for length, and all we do is add a prefix to it to make that number either larger or smaller. So if I were talking to you about the distance from California to Texas, I may give you that distance in kilometers. Okay, so I would add the prefix kilo. But if I were to give you my height, I may give you my height in in centimeters or even meters. Okay, so these prefixes will either make the numbers bigger or smaller. Now, here is the symbol for each prefix. What you notice is that for tera, giga, and mega, as well as deca, they are all capitalized, but the rest are all lowercase. Notice that we have two M's. We have a capital M for mega, lowercase for milli, okay? And we have a capital D for deca and a lowercase for deci. And then the other thing to notice is that micro has this funny symbol. It's a mu. It's called a mu, and it looks like kind of like an italicized U. In this column, we have the value of each. So compared to the base equivalent, how much does that value go up by? For example, if I add the prefix tera to the base unit meter, that increases the value by 10 to the 12th fold. If I add the prefix kilo to meters, right, to make kilometers, the kilometers is 1,000 times more than the meters, which was my base unit, the one without the prefix. Okay, and then this here is the base equivalent. Notice that the base equivalent is the reverse of the value in sign, or the inverse of it. So if the value is 10 to the 12th, the base equivalent is 10 to the minus 12. And this actually also means the reverse of what I just explained to you. So 1 meter is equal to 10 to the minus 12 tera meters. So the base equivalent is how much of this prefix added would equal to the base unit, the one that has no prefix added to it. So now we're going to go over how we would perform these conversions. To perform the conversions, we're going to use this base equivalence column. If your instructor likes you to memorize it, you can go ahead and memorize these. And what you notice about the base equivalence column, a good way to memorize it is, first off, I gave you the mnemonic down here. So the great monarch King Henry died drinking chocolate milk Monday night peacefully. And I highlighted in red each of the first letters, and the first letter is the first letter of the prefix. So it starts off at -12 and it ends at +12. Initially, they increase by the power of 3 and then by the power of 1. Okay, initially they're negative, and then once you get to the 1, they become positive. But notice that for each one, we're adding to the power. So we're adding to the power 3, another 3 to the exponent, okay, another 3, and then adding 1, 1, and then another 1 to the exponent. And then we add 1, 1 to the exponent again, then 3, 3, 3. Okay, now this base equivalent means that each of these numbers is equivalent to one of the base unit. So for example, if our base unit is meters, 10 to the minus 12 terameters is equal to 1 meters. 10 to the minus 9 gigameters equals 1 meters. 10 to the minus 2 hectometers equals 1 meters, and so forth. So these here are all equal to each other, okay? So that way we can use these as conversion factors. All right, so what are the rules for converting from one unit to another unit? So you always start off with what you're given. That's the first rule. So the unit that you're given and the number that you're given is what you start off with, okay? The unit that you're trying to cancel will go on the opposite side, and this refers to the conversion factor. So if I start off, let's say, with micrometers, and I'm trying to get millimeters, then micrometers will go on the bottom, okay? The unit you're trying to get will always go on the same side, and that's generally on top. Your final answer, once you're done doing the conversion, your final answer will have the same number of significant figures as the number that you started off with, as the number that you were given. And that's because within the international system, conversion factors have infinite significant figures. So they have no effect on the number of significant figures of our answer. And then the last rule is that it's best to put the answers in scientific notation. That way you can more easily show how many significant figures there are. And also if it's a very large or a very small number, you can show it using fewer zeros. Right, so I'm going to show you two different methods for performing these conversions. And remember, for each one, we're going to use the base equivalence. Remember, the first rule was that we start off with what we're given. So we're given 25.0 millimeters. So that's what we're going to start off with. And remember, the next rule was that the unit we're trying to cancel will go on the bottom. So in this case, we're trying to cancel mm, right? The little m, which stands for millimeter. So for millimeter, we're going to use this prefix here. And the number that goes with it, the base equivalence, is 10 to the third. So I'm going to put 10 to the third next to the millimeters. And then next, I'm going to go to the unit that I'm trying to get. What we're trying to get is megameters. So I'm going to put megameters on top. And then what I'm going to do is go over to this table for mega, right? Mega has the base equivalence of 10 to the minus 6. So I'm going to put 10 to the minus 6 on top over here. And as you can see, the unit millimeters here are going to cancel, and I'm going to be left with megameter as my unit. Okay, so the easiest way to do this is manually, but I guess you can also put it in the calculator. So this here, 10 to the minus 6 over 10 to the third, in order to calculate it, I just subtract the powers from each other. So I do 10 to the minus 6 minus 3. So when you're dividing two numbers by each other, their powers get subtracted. So this becomes 10 to the minus 9. So I have 25.0 times 10 to the minus 9. And remember, we said the rule is to put this in scientific notation. And we note that the significant figures is 3 because 25.0 has 3 significant figures. 1, 2, 3, right? I'm multiplying, so I'm applying the multiplication rule. So I have 1, 2, 3 here for 25.0. I'm going to put this in scientific notation. In scientific notation, this is 2.50 times 10 to the 1. And then I also have times 10 to the minus 9. So the answer to this problem is 2.50 times 10 to the minus 8. And our units are megameters. Okay, so that's it. So the first method, all you do is just place the units in the correct area, and then from the base equivalence chart, you put the correct number from the base equivalence chart with the correct unit, and then you just solve for it. That's it. Now let's look at the second method. So for the second method, we're also going to use the base equivalence chart, but for the second method, each of these units is first going to go to the base unit. So I'm first going to go to the meters before I go to the next desired unit. Okay, so for this method, we always first go to the base unit and then we go to the next unit that we're interested in. Again, same rule applies where we start off with what we're given. So I start off with 25.0 millimeters. This time, I'm first converting millimeters into meters. So the millimeters will go on the bottom, right? Because that's the unit I'm trying to cancel. The meters will go on top. Okay. Now for this next method that I'm teaching you guys, for this method that we're going over now, the number that we put with these will always be a positive number. So we can see from this base equivalence chart that the millimeters is 10 to the third, right? It's a positive power. And so all I do is just put with the millimeters 10 to the third. And the meters gets a 1. Okay, so now my millimeters cancel. And now I'm going to go from the meters to megameters. Again, the unit I'm trying to cancel, which in this case now is the meters, will go on the opposite side, which in this case is the bottom. The unit I'm trying to get, which is the megameters, will go on top. Now this is the part that's a little bit tricky. If I look at the base equivalence chart, I see that the mega, okay, is 10 to the minus 6. I don't want to deal with the negative powers, so instead what I do is I flip this conversion. I'm going to put the 10 to the minus 6, instead of putting it up here on top, okay, I'm going to put it on the bottom and change it to 10 to the 6th power. That way I'm just dealing with positive numbers. So this becomes 10 to the 6th, and this becomes 1. And again, this is equivalent as well. 1 megameter is equal to 10 to the 6th meters. And then again, now my meters will cancel, and I'm left with megameters. So I have 25.0 times 1 over 10 to the, since these are both in the denominator, add them up. 3 plus 6 is 9. Okay, so it's 10 to the 9th power, which becomes 25.0 times 10 to the negative 9. Because 1 over 10 to the 9th is the same thing as 10 to the negative 9. And then again, just like how we did before, I'm going to put this in scientific notation. So this is 2.50 times 10 to the 1, and then times 10 to the negative 9. So just like before, we get 2.50 times 10 to the, I add their powers, and that becomes negative 8. And the reason I add their powers is because I'm multiplying. And then my unit is megameters. So notice we end up with the same answer. Okay, so if your instructor doesn't care about which method to use, you can use whichever one you're more comfortable with. If they do prefer you to use one method over the other, make sure to do it that way. All right, now what we're going to do is look at units raised to a power. And what units raised to a power is when we have a squared here, for example. So here I have micrometers squared and centimeters squared. And that could have been to the third power maybe. Sometimes you might get to the third power, but it's called units raised to a power. And when we do this, this requires an extra step. Just like before, we start off with what we're given. So we're given 25.0 micrometers squared. Now, 25.0 micrometers squared is the same thing as 25.0 micrometers times micrometers, right? That's what the micrometers squared means. So the way that I'm going to do this is I'm going to have to do the conversion twice because I'm trying to go from micrometers times micrometers to centimeters times centimeters. So for each of those micrometers, I have to do the conversion once. So I start off with the 25.0 micrometers times micrometers. And first, I'll convert one of those micrometers. So the micrometer will go on the bottom. I'm trying to convert to centimeters. So centimeters will go on top. And from the chart, for micro, we have 10 to the 6th power. Remember, I'm using the base equivalence chart, not the value, but the base equivalence. For centimeters, I have 10 squared. So I'm going to put those numbers there. So 10 to the 6th power for micro, 10 squared for centi. And so what this does is that this cancels one of the two micrometers, but there's two of them. So now I have to do the same conversion again for the other micrometers. So same thing again, 10 squared centimeters over 10 to the 6th micrometers. And now this will cancel my other micrometers, right? So when units are raised to a power, you need to do the conversion as many times as the power, okay? So 10 squared over 10 to the 6th is 10 to the negative 4th, right? Because I subtract their powers since it's division, and 10 to the minus 4 here. So this becomes 25.0 times 10 to the minus 8, okay? And just like before, this is 2.50 times 10 to the 1, right? That's what the 25.0 is, times 10 to the minus 8. So the final answer is 2.50 times 10 to the negative 8, and our unit is centimeters squared. Okay, remember that the number of significant figures my answer has to match the significant figures I'm given initially in the problem. 25.0 has 3 sig figs, the answer has 3 sig figs as well. All right, so now let's go over the second method of solving this problem. Another way to solve this, which is the same idea, except I'm not going to write it out in the expanded form, is I'm just going to write this as 25.0 micrometers squared. And then I'm going to write the conversion, which is micrometers on bottom, centimeters on top, right? We said the centi, the value for it is 10 to the 10 squared. Sorry, the base unit is 10 squared. Micrometers is 10 to the 6th, okay? And then because it's squared, I also square this conversion here. So this becomes 25.0 times 10 to the, I multiply now these exponents. 2 times 2 is 4, divided by 10 to the 6 times 2 is 12. Okay, and then 10 to the 4th over 10 to the 12th is 10 to the negative 8th, because I subtract the powers. 4 minus 12 is negative 8. So this becomes 25.0 times 10 to the negative 8. And just like before, it's the same thing as 2.50 times 10 to the negative 7 centimeters squared. Okay. So now here are a couple of practice problems for you to perform on your own. So you can press pause, try this on your own, and then on the next slide is the answers. And here are the answers to the two problems you were given.